Okay, so I had you go ahead and write down your thoughts, and now I'm going to actually just put you in a breakout room with another person randomly, and you're going to share what you came up with, your thoughts on it, and just discuss why you think that that was the correct answer. So I'll give you just a few minutes, maybe 5 minutes to discuss it, and then we'll come back and talk about why we would use something like this in our lessons with students. Okay, any questions before I send you to your breakout room? Okay. Now I'm unmuted. Thank you. That's the biggest challenge with Zoom is paying attention to when you're muted and when you're not. So, so hopefully you had most of the groups that I checked in with had either different answers or at least some difference in answer. So that makes for a good discussion and why science can be so interesting, I think, and engaging is finding out what we think about things. And so the purpose of this is to solicit prior knowledge and what do you already know about the properties of materials and how it impacts their buoyancy, which actually is a very complex science concept. This is an easy way of getting students to expose what they know and what they think about things, and pretty low risk because it's not graded and it's not a test, right? So this is actually one of Paige Keeley's probes, and you'll be actually looking at these for an assignment. So to look at what is the purpose of this, there's a process, it's called PEO. And this article is posted so you will be able to take a look at it and read more about it. But it's about predicting, exploring, and observing, and how we can really get students to talk about what they think and know. Because what you'll find out, particularly next week when you're doing a study about misconceptions, is that students already have a lot of ideas about science and how things work. And some of those ideas can be very persistent regardless of what you teach them about the concepts. And so in order to overcome that resistance, you have to first identify what they already think. And then you have to actually confront any misconceptions directly that they have about how things work. And so this is the process by which we begin to do that. And in science, it's a very important part of our planning process. And so most students, when given this particular probe, will answer A. How many of you answered A and said that it will sink once you've popped holes in it? So, okay. That based on things that we've observed in the physical world, that would make sense, right? We tend to think of the water will be able to fill the holes and then it will weigh the object down and it will sink, right? Other students sometimes choose B and say that it will barely float, that because of the holes, it will just weigh it down a little bit and it'll keep it a little more under the water. And then, some students will choose D because they don't think it does either, so it flinks. So what is that, hovering somewhere in the middle? And that, so it'll sink, the water will get in, it'll sink, but then there's air in the holes that will keep it somewhat afloat and it'll kind of fall somewhere in the middle. So the answer to this question, the most likely answer is in this article. So I'm gonna require that you take a look. I'm not gonna give you the answer and read through the justification for the answer. So So the purpose was to have you experience a probe and to get an idea of how we can engage students in science and get them thinking about it and interested, like, okay, so now I'm intrigued. I want the answer to the question, right? I want to find out how this works, what makes things sink and float. And if we were in class, like we normally would be, we would actually do an activity where we explored lots of different things. And I would give you a whole tray of different items that you would test out and try to float or sink and see how they behave. And then you would start coming up with and refining new ideas about what makes things sink and float. And you would talk about that and express those. So this is an approach to science that's called inquiry, right? It may be very different than what you've experienced as a science student, where generally teacher gets up in front of the class and says, today we're going to learn about buoyancy. And they tell you all about what buoyancy is, what the formula is for calculating density, and how do you identify properties that would impact buoyancy. And you sit there and you listen and you maybe take notes, and then you move on to another concept in science, right? That's often how we have learned science. So we've learned about science, but what I just did with you and what we would have done more in depth in class is to do some science and for you to first like really think about, what do I think about this? And then explore it. How does this work? And then explain it. This is what I think happens, right? And if you'll notice, I'm using some E's here, right? So I engaged with the probe. I explored with I would take these items and sink and float them. I would explain, and then I would elaborate on that by actually doing some kind of content analysis or research. So that's where the teacher then can provide resources, support students in accessing information to really explain, well, why does this rock, which is made of pumice, actually float? When we would think, if we were categorizing items that sink and float, we would almost automatically put rocks all in the same category of, well, they're going to sink, right? So students begin to understand and see, oh, this has to do with how dense something is and the surface area of the object, right? And then we can bring in the science and say, oh, people have thought of this. This is what they've used to figure out whether something is going to be heavier or lighter or denser or less dense or sink or float, right? And how those work together. And then the students are the scientists and you're the facilitator. So that feels very different than just watching a video or reading a textbook or listening to a lecture and taking notes. And that's the kind of science we need to do with all students, but very much so with elementary students. So, any questions about that? The probes. So when we get to talking about week 3, you're going to get to see how you're going to use those, and you're going to do a little science study with some of your family members or siblings or friends using a probe. Okay? All right, so the other assignment that you have coming up for, I want to talk about week 2 assignments. And first we're going to talk about the nature of science assignment, and then we'll talk about the safety station assignment. And so some of you have already engaged in the safety science station with your groups and begun to plan that. And if you haven't, we'll talk more about that and how you need to get started on that. But first, I'm going to show you the nature of science assignment. So under week 2, you'll see that you have this nature of science, and then you have the nature of science survey. So the first part of this assignment is you're going to take the Nature of Science survey. And if you click on the Nature of Science assignment, it actually has these steps and it actually tells you how to take them, but it also has the assignment that you'll actually fill in. So if you open up that Word document, it looks like this. And so you're going to take the survey. You'll get a lot of these questions wrong, and that's okay. That's part of the process of learning what you do and don't know. And science is all about really what do we not know yet and what do we need to learn. So you're going to summarize the results of your survey. You're going to actually look at a few resources about the nature of science. So under resources for week 2, you have 2 videos and you have a document that you're going to review. And then you're going to come back to this nature of science assignment and you're going to complete this information about what you learned about the nature of science. The last piece is you're going to find an article. Good place to look is the WU Library or NSTA, which is the National Science Teachers Association. And you're going to find an article that has to do with scientists doing some kind of science. And then you're going to connect it to the NOS categories. So that's a brief overview of that assignment. Any questions up front about that? There's pretty detailed instructions on Moodle, both under the assignment, and then a new thing that I've added is I'm going to be doing little videos for instructions for each week. So you can watch this little video that'll tell you how to complete that assignment as well if you forget by the time you get to it. The other more complex project is the Science Safety Station. So raise your hand if you actually have already picked a topic and have picked your role in that group project. Okay, so it looks like Tanya, Bailey, Alondra, Kaylin, you guys are already on board with that. I know, I think Sarah has engaged with her group. So if your group has not started discussing this, you're going to want to go into the discussion forum that's linked here under week 2. And you're going to want to start a conversation with your group. So if you click on that discussion forum, it tells you who's in your group. And it also gives you an opportunity to post and respond to just the ones that are in your group. Okay. Madison, go ahead.
I posted for my group on Friday and I haven't gotten any responses. And so I was just wondering what the next step for that, like what else I could do.
So Madison, and I also see that none of your classmates are in this meeting that are in your group. So what I told the people in the Zoom meeting last week and what I'll tell you now is you don't have to wait for your group to post. You can go ahead and pick the topic for your group and just post it on the, so we have a Google Drive sign up. And so you just, there's 3 more topics to pick from. You just assign your group a topic and then you can go back to the assignment and you can look up the, if you look at the assignment on the safety station card, task card, it will have the different roles. So that is actually linked right here. And there are 4 assignments that are going to be completed. Each of you will pick one. So you get to pick first since you were the first to engage. And the nice thing about this group work is you can move forward without waiting for your group. And you will only be evaluated on your part of the assignment. It's not a group grade. So when you've completed your task, then you will submit it on Moodle. Only one person in your group has to submit the assignment. And you will submit as much as you have received from your group members. So hopefully those that haven't yet engaged in this, I will send out an email after this Zoom meeting with the link to the meeting and reinforcing that they need to engage in that conversation. So any questions about that part of it, picking a topic, picking a role in the project?
Can you repeat the last part of what you said? Sorry, I was reading the task card. Sorry.
So once you have completed your part, you hopefully towards the middle, end of the week, you will have heard from all your group members. What you will submit is a group project. Only one person in the group has to submit, and you will submit whatever has been completed up until the deadline. And so if somebody doesn't get their work done, it's on them. Okay. Any other questions about this project?
Are you wanting this on Google Docs or like a Google Slides type of thing?
You can do it on Google Docs or Google Slides or PowerPoint or Word, however, whatever makes sense. Some of you will be doing a little video or at least attaching a video. So what makes sense for a group project is usually a Google Doc or a Google Slides where you can add in collaboratively your work. So that would be fine. And then what you would submit on Moodle is the link to your Google document or your Google slide presentation. Just make sure to share it with me as well. Okay, so that is the week 2 work. You will actually get points for all 3 of those pieces. So the actual science safety station work that you complete, for posting, communicating with your group members. So if you, even if you don't hear from them, you should in your group post the topic and your role that you chose. That's what you need to put in there to get points for that discussion forum. And then thirdly, the nature of science assignment, which does need to be typed and submitted. Okay, so hearing no questions, raise your hand if you have a question, or we'll move on. And remember, you can always email me too if you have questions or sign up for office hours. So we do not have a Zoom meeting next week. So in order to help you to follow along with the assignments, I posted, like I said, those week 2, week 3 instructions. And so I'm going to just briefly talk about the week 3 assignments and how you're going to complete those. This pertains to the misconceptions, the probes that I mentioned. So you're going to actually do a video note assignment. And so before you actually get started on the videos, I want you to actually open this template and answer some questions. So it's important that you do that first before you watch the videos, because I want to see what your ideas are about the, oh, that's interesting. I can't see the, I'm guessing it's that one. See what your ideas are about these widely challenging concepts like, so for instance, the first question is, what causes the seasons? And so I want you to, without doing any internet research, and feel okay about exposing maybe your misconceptions here. I'll be the only one that looks at it. So why do we have moon phases? How does photosynthesis work? Can you light a light bulb with a battery and wire? So you're going to respond to those questions on page 1 and 2. And then you're going to go back to our Moodle page and you're going to actually watch these videos, the first 3 here. And it does tell you, some of these you won't watch the whole video. So make sure you pay attention to the instructions at the top. It'll tell you, like on the second one, I think you watch only the first 19 minutes. And what you'll learn from the videos is that a lot of people have misconceptions about science. And So as you watch the videos, you'll go back to your template and you'll fill it in as you watch those videos. So you'll see here for each of the 3 videos, there's a section for you to complete for your notes. Okay, so that's the first assignment. Then you'll submit that. And then you're going to actually, after realizing this information, you're going to go and pick a topic to do a misconception study with some people on. So I've posted a whole bunch of different topics. You can use one of the misconceptions that was in the videos you watched, but I've organized some of these by grade level. So if you're really interested in teaching 3-5 and you have access to some 3rd through 5th graders, then you might want to pick one of these that is suggested. And so this is the topic, you pick that, and then you go to our resources under this week, these Paige Keeley resources, and you'll see that there are a whole bunch of probes. So is it a rock, me and my shadow, summer talk? So just like the one that you did today in class, you're going to choose one to actually give to someone that you identify as your students for this project. So you can pick your parents, you can pick your siblings, your nieces, nephews, your friends' kids, your friends. You can do this all on Zoom or Google Meets or something if you don't have access to actually being around people. But you need at least 2 people to do this with. So you're going to give them the probe just like I gave you the probe. You're going to have them answer it. You're going to collect that work. Once you then see what misconceptions they have, then you're going to write up a little mini lesson plan where you identify what they, where you are going to address what their misconceptions are. And then you're going to actually teach them in a 15-minute activity about that concept. And then you're going to give them the probe again and see if they have overcome their misconceptions. So all of this is going to be written up in a lesson plan template that is the 3rd assignment, this section. So you have to include your probe, and then you have to complete this lesson plan template. So one of the reasons it's beneficial to use Paige Keeley's probes is she often has a lot of this information already in there. And I'm going to show you that in just a second. But here's what the lesson plan looks like. You'll be filling out who's your participants, what's your topic, how does this connect with the science standards, what are some of the common misconceptions that relate to this topic. Here's where you talk about what your participants did on the pre-assessment or the probe. What's the activity you're going to plan? Tanya, you have a question? Thank you for raising your hand.
Are we supposed to be seeing your screen as you're
talking?
talking?
Yes, I'm sorry. So I'm pointing to all kinds of stuff and you guys can't see it. So thank you for letting me know that. That better? So this is the lesson plan template. Can you all see that? Okay. So here you're going to describe the activity. Now this has to be more than just I'm going to show them a video that tells them why this concept is about what we said. You're going to actually try to engage them in some kind of hands-on work, like where they have to do something. And then you're going to give them the assessment again and see how they did and talk about that. And then you're going to reflect on this process and why is it important to actually use pre-assessments and access prior knowledge before we teach students about a science concept. Okay, so that's the 3rd part of this assignment for week 3. Does anybody have any? That's a lot to understand and process. So that's why I did this week 3 instructional video, which goes through what I just told you in even a little more detail. And will remind you of what I said, but I wanted you to think going forward, since we won't be meeting on Zoom next week, of what's coming up and prepare for that. So, any questions about the misconception study? I will say this is one of the, I think, the favorite assignments that students do in my class. They really enjoy stumping their kids, their classmates, their siblings, their parents. And some of these probes will definitely, it is very, very rare. In fact, only one time in all the times I've taught this class have I had someone who did not find any misconceptions with their topic when they gave their participants the probe. So very likely that you will find that they are not clear on some of the concepts. And you'll see that in the videos you watch too. So the videos are really interesting. I think you'll find them engaging, and so are and you'll definitely be going like, I don't know about that. So for instance, there is one video that talks about looking at a mirror and how much of your body you can see depending on how close or far away you get. And for me, that one, even as a science teacher, I was like, yeah, I don't believe that. Like, I had to test it out myself multiple times, and I still was like, oh God, that's hard for me to believe, because somewhere in my head, I had really convinced myself that it worked one way and it doesn't. So you will find some of those too for yourself. And that doesn't mean you're not a good little scientist. It means you are, that you have tried to naturally figure out what the world is like around you. So I'm going to give you just a few minutes. So those of you that are here and obviously Madison doesn't have anybody in her group to talk to, but some of you have participants from your safety station group. I'm going to give you the last few minutes of class to maybe connect with them and talk about how to complete that assignment. And then I will end the meeting. So before I do that and I break you up into those groups, is there anything you'd like to share, discuss, concerns? I'm amazed. I never get done early. So, has anybody looked at the answer to the probe yet? No. So before you leave, that will be your exit ticket today. So before you leave, you have to share with me what the answer is to the probe, and then I will let you escape from class today. And you can do that after you've touched base with your groups, if you have group members here. So remember, the answer is in that probe, and it is attached at the top of the page in our Moodle site. Oh, maybe not. Maybe it's actually under week 2. Yeah, the sink or float activity. Okay, I'm going to stop sharing my screen, and I'm going to put you in your safety station groups. That might take me just a second because I have to recreate them and manually do that. So breakout room 1 is going to be group 1, and that's going to be, let's see, we have Caitlin, Alyssa, Sarah, and Amari. So I think we have just, that's the other Caitlin, or Caitlin instead of Caitlin. We have a lot of Caitlin's, Katie's, or Kate's in this room. So this one should just be Amari and Sarah. So, and breakout room 2 is going to be, would be Madison, but since her group's not here, I won't break her out. So breakout room 2 is going to be actually group 3, which is going to be Maddie, who's not here, Larissa's not here, Bailey, and Alondra. And then breakout room 3 is going to be group 4, and that is Kevin, Tanya, Kaylin, and Caroline. So just Kaylin and Tanya. And then breakout room 4 will be group 5, which is Emma and Madison. Oh, wait, did I get Madison in the wrong group? Yep. So Emma, it looks like you have just yourself too. So you won't be assigned, you won't actually have anybody to be in your group with. And Madison, I'll assign you, sorry, to group 2. Can I do that? It's gonna let me. Yes. Okay. So I'm going to open the rooms. You'll go to those. If you don't have a room to go to or people to talk to, then you can just go look at the probe and see what the answer is. And as soon as you tell me, then, and you can just put it in the chat, or you can unmute and tell me, and then you can go ahead and end for the day. Any questions? Okay.
It'll float.
Got it. Who was that? That was Madison. Did you get the same answer, Emma?
Yes, I did. I just found it.
Yes, it will float because, can you explain that? Why? And how did that connect with what you had said? So Madison, did you pick the same thing?
Well, I said that it would float.
Yeah. And what
Yeah, and I said that it would sink, so it doesn't match what I said, but
yeah.
I kind of was just, I wasn't thinking like, I was just thinking like a paper plate or something, you know, and if you put holes in it, I feel like it would sink. So that's kind of where I based my guess off of, but yeah.
So I want you to try that at home now. Try a paper plate and see if you punch holes in it, if it sinks.
Okay.
And then let me know.
I will.
Okay. So, and then thinking about why it makes a difference, and then and how we look at things and we observe properties, and that's what we make our decisions on, right? Like that's how we explain our world. And sometimes we don't have all the information, or we generalize information. So, all right. Well, thank you for joining me this week. I hope you have fun looking through the other misconception stuff and the probes, and let me know if you run into any struggles or questions.
Okay.
Okay.
Bye.
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 For me to the probe.
Yeah, I do.
Okay, let's hear it.
It says that it will be the same floating material, so it'll still float. So
Correct. Amari and Bailey, did you get that? Well, Bailey, you already responded, but Mari, did you get that answer too? Oh, unmute.
Yeah, we were discussing it in the breakout room.
Excellent. So did that align with what you answered originally, or did you have to change your mind about that?
I had to change my mind. I originally put D, but I was going to put that it would float, but then I second guessed myself. So.
And we talked a little bit about that, right? Like the most obvious answer seems like we think science is often more complicated than it is. And so if we immediately know the right answer, it must be more complicated than that, right? So, yeah. And about half the people generally answer that it's going to sink. So, it's usually they think it has to do with the type of material that it starts with. So, I would, if you're still like, does this really work in all cases? I would suggest you try exploring that. Try some different materials and see, like a paper plate, and punch holes in it and see if it floats before and after, or yeah, and just explore. Does this true again across all materials, or like what if you used clay? Would it work the same? And see. So we'll touch base on this next week and see if anybody came up with some alternative answers. So, or 2 weeks from now. All right, any questions about the assignments or?
I do have a question. We were wondering, so there's some safety articles in the Read, Watch, and Listen. Is that where we're getting our info from for the science safety station, or are we doing the research ourselves and putting it into that safety station?
So those are some articles that are just examples. So they may cover your topic and they may not. So if they do, you're welcome to use them, but it just basically provides some resources for you to start with. You may have to go further to find stuff on your specific topic.
Okay, perfect.
And no, you do not need to add it. You don't need to put whatever you use in there.
Okay. All right, that was all I had, the questions I had. So.
Bailey and Amari, you guys good to go?
Yeah.
All right. Well, I will see you then in a couple of weeks. Have fun with some science. And I look forward to seeing what you find out about misconceptions.
Thank you.
Thank you.